Oeiras. 46 quilómetros quadrados de ideias e emoções com que damos forma ao futuro. Oeiras 27.
Great. Hello. How are you all doing? Good. Are you all excited to learn about some awesome science behind superheroes? Excellent, right. Well, you're very welcome then to the secrets of superhero science. Okay, so this afternoon, in very sunny Portugal, I'm going to talk to you about some real science that's happening right now that could create some of the superpowers you've seen in superhero films. So my name is Barry Fitzgerald. This is me on stage in February 2020, right before the lockdowns and pandemics. This is the last time that I presented in front of a live audience. Now on stage with me, I've got some things here that I've also got there, but there's one thing I don't have with me, and that is that big red glove, which is the Infinity Gauntlet from Avengers Endgame. Hands up here, who's seen Avengers Endgame? Who's seen it? Good. That's more than half the room. Right, so what I do is this. I'm a scientist. I'm also an author. I also write books. And my research as a scientist, it's all about trying to figure out the real science behind superheroes. And I also happen to work at this university, Eindhoven University of Technology in the Netherlands. I've written books, as I said, and this is one of my books. It's called How to Build an Iron Man Suit. And in that book, I talk about the real science and engineering you need to know to build an Iron Man suit. I have a very quick question for everybody. Who is that in the picture? It's who? Oh, that's Rocket, yeah, that is Rocket, you're right. But who's the guy? It is me, yeah, it is me. Not Iron Man, but it is me. Good call. Right, I love superheroes. I absolutely love the genre. I love watching the films. I read the comic books all of the time. And I think I'm after skipping a slide. Here's the ultimate suit up with Tony Stark in the Iron Man suit. That scene is probably my favorite scene with Tony Stark when he's putting on his Iron Man suit technology. Now, this is a list of the top 25 highest grossing films of all time. These are the films that have made the most money at the box office, at cinemas. And on that list, there are 11 superhero films. So anything with a star beside it is a superhero film. And I've seen these superhero films quite a few times. Here's an example. I have seen The Avengers from 2012 more than 80 times. So that's more than 80 times I have watched that film. I've watched this film, Captain America: Civil War, more than 40 times. Now, during this event, during this talk I'm doing right now, if you happen to see this on the screen, that will be your opportunity to ask me a question. So you'll see that later on, but I'm just pointing it out for the moment. But first, we are going to do a little bit of an experiment. I want everybody to stand up. Everybody stand up. Okay. And create a little bit of space for yourself if you can. Just kind of spread out a little bit. Just give yourself that little bit of extra room, okay? I want to see if this will work. That's good, yeah. So if you've got space in the back as well, just kind of spread out. What we're going to do here is we're going to do a group superhero pose. Okay, right. So what do I mean by a superhero pose? Well, you might have seen characters doing things like this. As a superhero, they have this pose they do. So what I want everyone to do right now is I want you to do the following. I want you to close your eyes. Everybody close your eyes. And I want all of you to think of your favorite superhero. In your mind, with your eyes closed, just think of your favorite superhero. I want you to think about their iconic pose. What's the thing they do when they're about to fight or when they're about to use their powers? Just think about that in your mind, with everyone with their eyes closed. And what I want you to do is, on a count of 3, with your eyes closed, I want everyone to do that pose. Or, if you don't happen to have a favorite superhero, make one up. Okay, is everyone ready? So 3, 2, 1, all eyes closed, do your pose. Some people are doing their pose. I'll do it as well, right? So you can all open your eyes and then see everybody doing it. I'm going to do it, okay? So 3, 2, 1, here's my pose. Okay? So how about the rest of you? Are you all going to do it as well? We'll go again on 3, 2, 1, superhero pose. Okay, some people did it, some people didn't. Okay, that's great. You can all sit down. You can all sit down. That was an experiment to try something out, see if it would work. Don't think it did. Okay, right, let's get into some of the science. Secrets of superhero science. So there are plenty of examples of superhero scientists and engineers. There's Shuri from Black Panther. There's Tony Stark, who built the Iron Man suit. There's Janet Van Dyne, who you might know from the Ant-Man and the Wasp film. There's Reed Richards from the Fantastic Four. And there's also Cisco Ramon and Felicity Smoke, who you might have seen in the TV series involving The Flash or Arrow. Now, there are many ways to become a scientist, and there are many ways that I think, anyway, to create superpowers. And today, what I'm going to do with you is I'm going to talk to you about 4 different superpowers and the science behind creating those 4 powers. And all of the science I'm going to present you here is 100% real. I'm going to start off with the first one, and that is unlocking what I call our genetic superpowers. And to motivate this and to give you an example of a character with genetic superpowers, I want you to look at this clip.
Dr. Banner, now might be a really good time for you to get angry.
That's my secret, Cat. I'm always angry.
There you go. That was the Hulk, or Bruce Banner, turning into the Hulk in the 2012 film The Avengers. So right, let's think about the Hulk for a moment. Would it be possible to actually do that, to turn into someone who's about the same height as me, into someone who's big, green, and has super strength? Well, if you're going to talk about answering that question, you need to start thinking about DNA. Now, I'm sure everybody here has heard of DNA before. Everybody knows that every living thing has got DNA. Everyone's DNA code is different to some extent from one person to another. And if you were actually to write down your DNA code on a piece of paper, it would look like this. That is what your DNA would look like. It's just a bunch of letters, and it's only 4 letters, A, C, G, and T, and these 4 letters represent what are known as nucleotides, and these are the components of your DNA, and there are 3 billion sentences, effectively 3 billion pieces that look like this in your body, in your DNA. So it could be a massive book, but not a very interesting book to read if you were to print this book. Now, our DNA contains genes, and genes are really important for our body because they make proteins, and your body is making proteins every single second of every day. These are two proteins your body is making right now. Collagen, which you'll have in your skin, and hemoglobin, or red blood cells, which of course are important for bringing oxygen around your body. Your body is always making those proteins. Now, the question though is, can we change how our body makes proteins and what type of proteins our body actually makes? Well, we can, potentially, with something called CRISPR-Cas. Maybe some people have heard of CRISPR-Cas. What CRISPR-Cas is, it's basically a scissors. It's like a tiny, minuscule scissors that you can put into a cell. It can find the DNA, and it can cut out a piece of the DNA. You might want to treat a disease before it ever happens, or you might want to put in another piece of gene or DNA into someone's DNA. Now, it sounds quite simple when I describe it like this idea of putting in DNA and taking out DNA, but it's a really complicated process and something that is very difficult to achieve. But this technique is brilliant, and it was developed primarily by these two individuals, Jennifer Doudna and Emmanuel Carpentier. The two of them together, they won the Nobel Prize in Chemistry in 2020 for this amazing, groundbreaking genetic engineering tool. And the reason they won it is because this is a really accurate way of changing DNA. And if we were to change people's DNA, that's exactly what we need, something that's really accurate and doesn't make mistakes. And in fact, they were getting notice about this even back in 2014. And in that picture, there's a Hollywood actress, Cameron Diaz, presenting the two scientists with an award for their amazing work. This is brilliant. Now, what could we actually do with CRISPR-Cas? Well, people are already doing things with CRISPR-Cas. For example, a group of scientists decided they wanted to change mushrooms. So they genetically modified the mushrooms so that they never go brown, so that they never look like they are expired. Another group of scientists used CRISPR-Cas to change zebrafish so that instead of growing fins, the fish actually grew legs. So they made the fish grow legs. So there's some possibilities here about what you could do once you get proper approval. What about doing something like this? This is brilliant. We are in an age where we create lots of data. Lots of you have smartphones, right? And you're sending text messages or storing people's phone numbers or taking photographs, and you need memory on your smartphone. But DNA could be used to store data. And this is a study from some researchers in the United States. It was published in 2017, and what they did was they took E. coli bacteria, they changed the DNA of the bacteria so that you could store a full video of a horse running. They were able to store videos in bacteria. So perhaps in the future, you won't be using storage devices to store your photographs. Instead, you might actually be using bacteria in a smartphone device in the future. But what about becoming green like the Hulk? Is that possible? Well, someone has kind of done it already. This is researchers from about 14, 15 years ago. What they did was the following. They took some rabbits and they injected the rabbits with the green luminescent protein from a squid. And then the one rabbit had some baby rabbits, and some of those rabbits were born with that gene in their DNA. And when you looked at them in very dark conditions, they actually would glow in the dark. So they were able to create glow-in-the-dark rabbits. Maybe you're thinking that's not very ethical or a good thing to do, but it shows that this could be used potentially to make people glow. And I'm Irish. Maybe you can tell from my accent that I'm from Ireland. If you were going to celebrate St. Patrick's Day and you had the power to glow green, I think that would be quite useful, particularly for St. Patrick's Day celebrations. But there is a problem with all of this, and it comes down to ethics. Should we do it? Should we change someone's DNA? Is it safe to change someone's DNA? And that's going to be debated for many, many years because it's something that could lead to lots and lots of problems. If you decide to become a geneticist or someone who's going to change DNA, you've got to be ethical about it, and you've got to make sure that you get permission to do it, because we have had examples of people who did not get permission to make changes to human DNA, but they still actually did it. Right, does anybody have any questions before I move on to the next part? Yes? My university is in the Netherlands. Does it have? Does it have the programming courses? Yes, it has plenty of programming courses. Eindhoven University of Technology. Yes? Yes?
The green lights, like, that really blown up, were rabbits?
They're rabbits. Yeah.
Didn't seem like that.
They don't look like rabbits, yeah. So the question was, were they really rabbits? And what the rabbits had is they had a protein in their DNA, and when it's very dark, if you look at them in a dark room, that protein would turn on, and it happened to allow them to glow in the dark with this green color. And this is the same protein they took from squids or from fish, basically, and they put it into the rabbits. But they really did glow in the dark. Yeah. Does anybody else have any other questions before I move on? Yes? Oh, the emotion element with that's a really good question. So the question is, with Bruce Banner changes into the Hulk because he gets angry. And if he gets angry, then he has this huge transformation to his body. So if he's getting angry, then it changes the degree of hormones that are released into his body. So it could be adrenaline, it could be cortisone, it could be other hormones and elements. So I actually think there's a semblance of reality there, because we do experience adrenaline rush or cortisone rush when it comes to fight or flight. So if you were able to maybe put that up again to another level, maybe you could replicate the degree of the rush that you get from the transformation, but not necessarily the transformation itself. There are lots of people who say on an adrenaline rush they could do things they could never do if they weren't experiencing that. So if you were able to push it to another level, then they could maybe do something extraordinary, but the drop would be huge. Think about the drop coming from that huge adrenaline rush back down to normal. How the body would respond to that would be very interesting. I'm going to move on because I have 3 more sections to go through. So what I've done is I've looked at DNA and kind of thought about changing DNA to give people superpowers. What about this? Freezing people or freezing super soldiers. So if anyone has watched Disney Plus and the What If series, you might have seen this character. This is Captain Carter, Peggy Carter, and she gets the super soldier serum in the series. But in the movies, there's this guy here, and that's Bucky Barnes, who is also known as the Winter Soldier. And in one of the films, we actually get to see him being frozen, and this is the clip from the film.
For everybody.
Okay, that was short and sweet, but that is freezing somebody. Now you might think, wow, that's super cool. Could we actually do that? But before I answer that question, I need to go through some of the things you just saw. Was that a cryosauna? Because it looked like it was a cryosauna. A cryosauna, which might look like this, is something that people can get into, and you are exposed to very low temperatures for a very short period of time. And during that very short period of time, it can help to, for example, heal your body if you've experienced an injury or a muscle problem. Being in that very cold temperatures of minus 100 degrees Celsius for 3 minutes can actually help your body. Any longer, then you're going to experience maybe some bad things for your body. But if you're to freeze somebody, there is a big problem, because you have what I call the H2O issue. You are 70% water. If you freeze water, it turns into ice. If it turns into ice, And inside the body, that is, they can be sharp and pointed crystals of ice in your body, which can burst your cells. And if they burst your cells, then your cells will be damaged forever. So that's not the way to do it. How about you turn to something like cryoprotectants? These are chemicals you can put inside the body which will prevent water from freezing, but the problem is with cryoprotectants is they'll actually poison your body and kill your cells. You don't want that either. Don't worry though, there is a natural solution to this problem, and the natural solution to the problem is contained in that. That is the Arctic Ocean pout fish. This fish can swim in the Arctic Ocean in incredibly cold waters, but it doesn't have to worry about ice forming inside its body because it produces anti-freeze proteins. And these proteins can bind to the water crystals and stop them from growing, and as a result, protect their cells. And I know some researchers who are actually working on this. This is Ilya Voots from the Eindhoven University of Technology, and she actually has written a paper about this, about how you could turn to the ocean pout fish to figure out how to freeze the winter soldier. And this paper is actually published in my own journal. So this is a journal that I have in the Netherlands. It's an open access journal called Superhero Science and Technology, and she published about this exact research area. So this goes to show you that people are actually trying to figure out whether we could do this or not. Now, before I move on to the next part, does anybody have any questions about what I just spoke about? Anybody? Yes?
Is there a way for us to inject it on our body?
Is there a way for you to be injected with? With this?
Your own body.
With the antifreeze proteins? So would you like to have the antifreeze proteins? Yes. May I? Okay. And why would you like to have them? Very good answer. He just said that you'd like to go to very cold places. Not. And now you're on the right track about what they want to do with this. So you just said that the person at the front has said that he'd like to freeze himself so that he could travel to a planet in another part of the galaxy or in space. And what the researchers want to do with those proteins is freeze organs for organ transplantation. Because if organs are taken out of a body, you have maybe 6 hours to use them. And if you don't use them, they go to waste. So what's the best way to save those organs? Put them with these proteins. You can have them for longer, which means that you could save more people's lives with this. Yes? Not being used yet, but it will be. It will be used. Sorry, you're just looking at your phone. You asked me a great question. It's an awesome question. So what I want you to do is at the very end of this talk, I want you to come up here to me, and I'm going to give you a copy of my book, Secrets of Superhero Science, okay? That's for you, right? So come up to me at the end. Right. A round of applause. Okay. I'm going to move on to the next section, and then I'll take your questions then after that. Right. We've done freezing, and we've talked about, well, preserving people and allowing them to live for longer, perhaps, or saving organs. What about spider silk? Now, I've got a really great story to tell you about this, but before I tell you the story, I want you to have a look at this clip.
125 seconds until catastrophic failure.
What? Why?
Unexpected motion has caused the deterioration to escalate.
How do we get in there?
Activating reconnaissance drone.
Whoa. Has that been there this whole time?
Okay, so that was Spider-Man climbing the Washington Monument. And Spider-Man, I think, is probably one of the most iconic superheroes. I cannot wait for the new Spider-Man film, Spider-Man No Way Home. It looks and could be awesome, having all of this multiverse stuff and multiple spider people, and it's going to be amazing, I'm pretty sure of it. Now, the thing about spiders, I've decided to put an animation of a spider here, and not a real spider, because I know some people might be afraid of spiders. Spiders, we know, can climb walls, but they also can produce spider silk. And spider silk is a pretty cool material. It is one of the strongest natural materials on the planet. It is extraordinary in what you can do with this material. So it would be great to maybe be able to produce more of this for particular applications. Now, spider silk is a protein. Remember earlier on I talked about proteins that are being made in our body and also these antifreeze proteins. And proteins, well, we normally find them in our food, of course, in dairy products, for example. And as I said, our body is making proteins all the time. But this is a researcher from the Netherlands who I know. Her name is Jelilia Saidi, and she had an idea. She had an idea to do something very cool with spider silk. But she needed to get enough spider silk to do it. Because the problem is, if you take a bunch of spiders and you bring them into a room and you want to take spider silk out of the spiders, well, that won't work because the spiders will actually start to eat each other. That's what they'll do. They will actually eat each other. Not exactly what you want to happen. So she decided to make the factory bigger thanks to some researchers in the United States, and they turned to something that's actually called a spider goat. So a researcher in the United States of America, his name is Randy Lewis. In 2000, he decided to do the following. He took a goat and he changed the DNA of that goat so that when you milk the goat, it produces not only the protein for milk, but also produces the protein for spider silk. And then they were able to take out that spider silk protein from the milk and then use it for, well, whatever they wanted to use it for. This is how they figured out how to make spider silk, and lots of it, in a safe, ethical way, by the way. They got full permission to do this research. And these goats, there are farms of goats in the United States. You can see a bunch of these goats in a field eating grass. They don't know that they produce another protein, but they make that spider silk protein. So what did Jelilia do? She did the following. She took some of that spider silk, she combined it with leftover skin from plastic surgery, and she created a material that is bulletproof spider silk human skin. This is a material that can stop bullets traveling at 175 meters per second. This is a real bulletproof material. They tested it at the forensic laboratories in the Netherlands, where they had snipers firing bullets at it, and the bullets did not go through it. And it is made from spider silk, which is absolutely extraordinary. And I have one question for you, and I didn't mention this. Would you drink the goat's milk? Hands up here who would drink the goat's milk. I would drink it. It's perfectly fine. Because I didn't tell you something about spider silk. Spider silk is non-toxic. It will not kill you, and you can eat it, but I'm not suggesting that after this talk you go outside and start looking for spider silk to eat. It is completely safe. You do not have to worry about it being poisonous. Does anybody have any questions they would like to ask? There's a question just here. Yeah. Yeah, please.
Is it possible to make a web shooter?
Is it possible to make a web shooter? So, the web shooter is a piece of technology. You can definitely make the technology. What you need to make then is the web for it to shoot. And perhaps you could use this type of material, but the problem with this material, that the spider silk that's coming from goats, it's a biological material. It will start to break down very, very quickly. But there are researchers who are coming up with fake or artificial ways to make spider silk. So the hardest part is not making the shooter itself. The hardest part is finding the spider silk for the shooter. But there are researchers who are now figuring out how to do that. So I'm going to say yes, absolutely. You could do it. Yeah, just here. Yes.
Would you be able to build an armor out of that type of web?
Yes, you could. That is a brilliant question. There are people who are looking at making things like bio weaves. That's a material that contains, let's say, inorganic material, something like a metal or something, you know, that we would have like an iron or titanium, but they'll weave in these biomaterials in there, something like that spider silk, so that you combine the best of both worlds. In fact, the best material that you could combine with spider silk is graphene. And graphene is one of the strongest materials on the planet, but it's, you know, it's synthetic. It's carbon atoms in this very, very regular arrangement. People are trying to figure out ways to make it. But if you combine it with spider silk is tougher than graphene, but graphene is really strong and a great electrical conductor. So you could combine the two materials together to make really, really strong materials that could protect you, but also materials you could use in electronic devices. That's a really good question. Yes? There's a microphone coming your way.
We can grab a bunch of goats and make a web factory.
If you want to, you could. Yeah, you can have goats, a farm that produces two products: spider goat milk and spider goat silk. So you've got something that would be worth doing. I'm going to move on to the last section, but what I'm going to say is this young man in the red, if you just grab his attention, your question was fantastic. Come up to me at the end. You're going to get a book as well, okay? That was a great question. Fantastic question. Okay. Let's move on to the last section. And the last section, after looking at spider silks and bulletproof materials, is the power of invisibility. And I'm going to show you that it is perfectly possible to be invisible or make part of you invisible. So before I do that, I want you all to have a look at this. Right, that was Hawkeye in has anyone seen the What If series on Disney+? Anybody watched it? Yeah, I see one person has. I've watched it all, like, multiple times. That's a scene from one of the episodes. It shows Hawkeye, this guy here, who has an invisibility cloak. And it might be something that you might think, well, that would be kind of cool for Tony Stark's Iron Man suit as well. But let's move away from Tony Stark and Hawkeye for the moment. Invisibility is something that for years I thought would be impossible. And as it turns out, it's completely possible. This image I'm showing you on the screen is not a photoshopped image. I have not changed this image. I have not played with this image. This is a real image, and it is an invisibility cloak called the Rochester cloak, developed at the University of Rochester in New York State. And this is the PhD student who worked on it. His name is Joseph Choi. Now, you can get the instructions to build this online. For example, there's a Wikipedia page with the full instructions for building this invisibility cloak. And I know this works because I've built my own version of the cloak. That's it on the screen. That's it on the table. It really, really does work. And I even wrote about it in a scientific paper about what you can do with this cloak and what you can learn from it. And here is me in the middle of a test with the cloak. So I put my hand in between, and that's my right hand. I've still got all my fingers. It's still fully there. That's not a trick. But I know some people will tell me, Barry, this is still a trick. I think you're telling us a lie here. You're going to have to prove it. So what I'm going to do is, can I take one person from this side who wants to come up? Can I take you? Yeah. I'll take one person from this side to balance it right at the very end. Yeah? Great. Okay, so can you come up here first, up to the stage? Whoever wants to go up first. So I just got to check something, make sure everything works. Yeah, it does. Okay, so what I need you to do is this. I need you to come to about here. I need you to kneel down and look straight through the lenses. So I'm going to ask you some questions so that it's all very transparent. Do you see this man's head? A giant man's eye? Do you see his? Do you see the bridge? Do you see this part, the green part? No. So you don't see this, but you do see that. Perfect, great, it works, but I need someone else to check it, so I'm going to get you to check it as well. Again, just need you to look straight through. So what do you see? Do you see this guy's head? You do see that. Do you see the bridge? No, you don't see the bridge. Thank you very much. A round of applause for both of my people who checked there. So that is a real invisibility cloak. I'm not making this up. This is real physics. It really, really does work. And my question to you is this then. If I gave you an invisibility cloak right now, what would you do? Hands up. Anybody want to tell me what they would do? What would you do? Sorry? Be like Harry Potter, is it?
Research.
Military research. Okay, you'd use it for the military reasons, okay. Okay, if it's for the UN peacemakers, then I'm pretty happy with that then. Anybody else want to tell me what they would do with an invisibility cloak? Nobody has any other ideas? That's okay. Right, has anybody got any questions about the invisibility cloak? Anybody have any comments they want to share? Anybody have anything? Yes, sorry. Lost you. So if you can ask that question actually, please, that'd be great.
I didn't understand how it worked, really.
That is exactly what I wanted someone to ask me. You've asked exactly the question I wanted. How does it work? Okay, so I'm going to explain how it works. That's a great question. So how it works is this. Here's the invisibility cloak in front of me, right? So what happens is the following. Light will hit this guy on the head. And the light then will bounce off of that object. And when it bounces off the object, it gets reflected and it moves through these lenses. And what happens is that when it hits this lens, its direction will change. It will bend in another direction. In the same way that the glasses I wear bend light when they fall on my eyes. So the light gets bent in a certain way here, gets bent in a certain way here, here, and here as well. And when it comes out the other side, I see the light from this particular person, the head of this character, but the light has been bent by these lenses so that it goes underneath the bridge. Which is why, I'm going to show you a trick here, which is why, with this image here, why did I use my fingers in the image? Anybody want to know? Anyone want to give me an answer to that? Because this is a question here. Anybody know why? The reason is this. If I put my hand in like this, you would see the center of my fingers because it doesn't cloak or make that central part invisible. But if I spread my fingers out wide, I can make sure that my fingers aren't seen, but the part that would be seen would be somewhere around there. So it's not a full invisibility cloak. It's almost a full one, but there's always a piece that you'll always be able to see. Thank you for the question. At the end, please come up to me as well, because I'm going to give you a book as well for that question. Thank you very much. Okay. Right, we're on to the last part. And the last part is in relation to the following, after talking about invisibility. One last thing is this. Everybody fails. Now, that's not a bad statement I've just made. It's just the way the world works. Everyone fails, but do not be afraid of failure. And one person who knows a lot about failure is Tony Stark, because in the Iron Man films, he made a lot of mistakes when he was building the first Iron Man suit until he got it to work. And when he got it to work, well, it did something like this.
Day 11, test 37, configuration 2.0. For lack of a better option, dummy is still on fire safety. If you douse me again and I'm not on fire, I'm donating you to City College. All right, nice and easy. Seriously, just gonna start off with 1% thrust capacity. In 3, 2, 1.
That is Tony Stark when he was building the Iron Man suit. But at the very start of that clip, he mentioned something really important. It was day 11 that he got this to fly, which meant that 10 days of failure got him to that stage. And there's a great lesson to be learned here that any success you have will always be built on a solid foundation of failure. Do not let that put you off. It did not stop Tony Stark from building his suit. And if you're doing anything, whether it's in sport, science, whatever it is, do not be perturbed by things not working out as you planned. If you want to see more about what I do and what I talk about, first of all, you can check out my YouTube channel. It's called The Superhero Scientist. You'll find videos on there about lots of superhero content and lots of different episodes and films and other science elements that I talk about. I'm also on social media as The Superhero Scientist, and I have my Twitter account, and I'm also on my website. And I've got books, as you know, How to Build an Iron Man Suit, and I have 2 other books, Secrets of Superhero Science and Secret Science of Santa Claus, who, to be honest, for me, is the ultimate superhero. All of my books are on sale in the bookshop behind you during the festival as well. So I hope you enjoyed this presentation. This has been The Secrets of Superhero Science. Thank you very much for listening. If anyone has a couple of questions they want to ask right at the very end, I'm open to answering those questions. If you don't, that's fine. Those who I'm going to be giving books to, please come up to me at the end and I'll give you the book as well. There is one question I see.
What's that other thing in your table?
Oh, right. Okay, I didn't show you this. That's a great question. I didn't know if I had time. I think I have a little bit of time. Right. So this is an exoskeleton suit. This is basically what you would be looking to build if you were trying to build the Iron Man suit. So I'm going to put it on. So you put it on like a coat. And it's basically, I'm going to take my phone out of my pocket as well, so it's not there. It's the basic structure of any exoskeleton suit you want to build. So if you're building like the Iron Man suit or anything else like it, right, so, and I need to put that in place, right, so that's it on, that's my exoskeleton suit. Now you might be wondering, what does this actually do? So what's it used in is healthcare. So if you were working in a factory, and if you were moving boxes from one point to another, or if you were lifting things, this is a type of technology which protects your body from harm. And it does it with the following. So I'm walking around, no problem. It's a little bit clunky when I'm walking, but other than that, it's okay. However, I hope you can all see this. There is a clip on the hip. Does everyone see that black clip? And there's another one here as well. So what they're actually connected to is a spring. So I'm going to turn them on, activate the 2 of them. I'm going to have to do that one again. There we go, and there we go. Now, those springs are now active. So when I bend down in this, I feel the plate here at my chest is pushing against my chest. And what it does is it takes my upper body weight and puts it on my legs. So if I was in a job where I had to be in this position all day, it protects my back. And it also, in some way, then takes some of the weight and stress off my body and a little bit off the upper body as well. So you could have someone who's working in a postal delivery office who's doing that all day, or is moving objects like this and picking them up all day long. You could even have someone working in a hospital who might be lifting patients out of beds. And this was one of the reasons they developed this suit, so that you could lift someone up like this and move them to another location, protecting your body. This is just one example of an exoskeleton suit. I'm trying to get my hands on a whole bunch of others. I have an exoskeleton arm as well. I didn't bring it with me today. So if you're here and another day during the festival, maybe you'll see me have an exoskeleton arm on as well. So I have one of those too. And then if I want to turn it off, got 2 clips there. It's now off, and I can walk around as I wish. And this is just a piece of advanced clothing. And if I want to take it off, I take it off just like a coat. And that's the exoskeleton suit. Thanks for asking that. Anybody else have any other questions before you're done? I think there's one just over here, yes, and then we have one at the front, and then we'll leave it at that then.
If I was wearing an invisibility cloak and I grabbed something, would it turn invisible?
So if you were wearing an invisibility cloak and you robbed something, would it turn invisible? No, you'd have to actually have it underneath the cloak for it to be invisible. But one question that I got asked once, I was given a talk at a bookstore, and an 8-year-old person, an 8-year-old child asked me, so if I'm wearing an invisibility cloak, how could I see? Right? It's great. It's an awesome question. So if you were invisible, wearing the cloak, how could you then see? And my answer was, well, I would hope that when the technology is developed, that people will figure out a way that certain light can pass through the cloak and other light doesn't pass through. So it still allows you to see, but doesn't give away where you actually are. I thought it was a great question. I think there's one more question just up here at the front, and then we're done. Yeah, we're done then. We're done now. Yeah, that's it. We're done. Sorry, unfortunately. Thanks very much. I hope you enjoy the rest of the festival. I hope maybe I'll see you again over the course of the week. Take care, and my last thing I'll say to you is always think super. Thanks very much. Thanks.
Oeiras. 46 quilómetros quadrados de ideias e emoções com que damos forma ao futuro. Oeiras 27.